Today we are going to talk about the machine learning models which we can deploy on the TinyML embedded systems. What you need to know before you start your TinyML project. So there is a Tensorflow Lite model which begins the hype of implementing the neural networks on a microcontroller, and many libraries and frameworks come in to do this task. But the TinyML is not just about deploying the neural networks on the embedded systems. It is a lot more than that. Any machine learning model that you can deploy on the embedded system, so it would help you in the just like the embedded systems help you in your day-to-day task or any project that where you want to use machine learning, could be a part of the TinyML task. So we are talking about the timeline of the machine learning, how it goes, and we are also going to talk about some amazing machine learning papers which make this neural network deployment on the embedded systems possible. We are going to talk about famous examples of TensorFlow. We are going to look into latest tools developed by MPLab and ST microcontrollers. So we are going to talk a lot about that. So if you want to keep the content like this, you can leave a comment what kind of topic you want to know more about the machine learning. So recently the MPLab launches a development suites for 8, 16 and 32-bit microcontrollers and the microprocessors. As you may already know that microchip have a vast variety of embedded microcontrollers, and it comes from a range of 8-bit, 16-bit and 32-bit. It also makes a DSP version where the DSP related tasks are possible. So now it jumps into a TinyML field as well. So you can start a plugin, you can add a plugin in your microchips MPLab, and you can start building a project where you need a machine learning. So what you need to make considerations before you start selecting a model for your embedded systems. As you may know that there are many challenges, just like the processing bits that 8-bit microcontroller, 16-bit or 32-bit, that maximum you have, they are limited in number, the quantity available as a flash memory and a RAM. So all these challenges need to be considered before you start your machine learning project. So how a simple machine learning project is modeled. So here is a simple block diagram which explains how embedded systems based TinyML model works. So first of all, you collect some raw data. Normally the sensors that are available on IoT devices or the embedded systems or any project where you need, just like the Arduino, the STM32 board. We will talk about what kind of platforms we have available for the machine learning models, but before we need to know what kind of sensors could be interfaced with the embedded systems or the microcontroller you are working on. So for example, we are working on Arduino or Raspberry Pi or the Raspberry Pi Pico, or any Jetson Nano you are working. Jetson Nano is capable of doing some machine learning with the GPU capabilities. So you need to know the limitations of your microcontrollers. So you collect data from some sensors. So for example, you collect data from a microphone, you collect data, a time series data, you collect data from some sensors available with the camera, just for you are doing object detection, you are doing a classification model, you are doing a text input. So you need to make some methods to take the text input. As I had created a video on doing a very constraint limited implementation of the sentiment analysis. Either you are doing a speech recognition project, so you need to interface a microphone if you are doing a gesture recognition, you need some kind of accelerometer to connect with your microcontroller. If you are doing some pose estimation, you can connect the Microsoft Kinect sensor to your microcontroller or your microprocessor. And on device recommendations, there is a list available on tensorflow.org light examples page. So you can create a lot of projects. Although this list is available for Android as well as Raspberry Pi, there are some versions available for Raspberry Pi, Android, and iOS. Basically, when the TensorFlow launched its light model, the main purpose for this light version of TensorFlow is to make the machine learning models infer on the mobile devices, just like the Android devices, and later it is adopted on iOS. So after that, many researchers jump in to explore the capabilities of this TensorFlow light model and turn it into a TinyML version, where this TensorFlow runtime is implementable on a mobile device, on edge devices. So what you need to know before you start building a project on a TinyML based project or machine learning, where you implement your model on a constrained, limited resource, limited device like microcontroller, like Raspberry Pi Pico or Arduino. There are bunch of available devices which supports the TinyML built-in. The Arduino Nano Sense is one of the major used machine learning based edge device which you can use for your machine learning models. ESP32 supports the TensorFlow, so you can make many machine learning projects on ESP32 as well. If you go back on the time machine of the machine learning, here is a Wikipedia list which talks about when the machine learning starts to happen, although it is very difficult to say when the actual machine learning comes into play. But according to Wikipedia, there were statistical analysis in the machine learning. So you need to know very detailed about the stats. You need to learn the statistics, how to apply it to learn about the data, because the machine learning is all about data analysis. You learn about the data, you predict about the data, you recognize something, you predict something. So first of all, there were 1950 statistical methods are discovered and refined. And in 1950s, the pioneer machine learning research is conducted using simple algorithms. And in 1960, the Bayesian methods are introduced, and the machine learning got a lot better with the probabilistic inference. So you need to know that you don't have to jump onto a complex neural networks if your problems could be solved with a simple Bayesian method, or your problems could be solved with a simple rule-based systems, or your problem could be solved with some fuzzy logic systems. So these are the models that are capable to infer on the embedded systems. So if you are using an embedded systems based project, if you are doing some project which need machine learning and that model need to be inferred on or deployed on a microcontroller or microprocessor, try to think about the problem and try to learn, does that problem is able to be converted on some statistical methods or a machine learning based models which are possible to be deployed on microcontroller, just like the KNN, the regression models, the previous statistical based models. So you connect your sensors, you implement some filtrations, you pass data to the ADC, you convert that analog data into a digital. Now you have a digital data. You can train your machine learning model on that data, and that data will predict in some categorical basis. As in this example, a fetus heartbeat is detected using a piezoelectric sensor and passed in a bandpass filter, and ADC convert and digitize that analog data into a digital form, and a trained ML model predict either that heartbeat is normal or abnormal. So that's one kind of project which this person is working, the Shahzeeb Ali is working on, and there's a link to an article about that. Let's move on and let's talk about you trained your TensorFlow model on the Python, and you want to reduce the size of your model. Before you start jumping to deploy your model on embedded systems, you need to know how to reduce the model size, because when you train the model, it is a huge in size because it is trained on a huge data. So the machine learning training model in a TensorFlow or PyTorch is trained to keep in mind that it is being trained on a GPUs, TPUs, or heavy machines, but the microcontrollers are not that resource available. There is not much resources available, so you need some techniques to reduce the model size. So there is a model with a 744 megabytes existing model, and you need to quantize that model and reduce that model size. So what are the methods available to reduce the model size? There is a purring method, there is a quantization methods available. We'll talk about all of these in upcoming videos, and we'll talk about how to use them. But let's come back and see back onto our TensorFlow Lite. So you have a TensorFlow library available for the Arduino platform. So if you wanted to start your machine learning journey, you can consider some microcontroller board like the Raspberry Pi Pico, the STM32 devices, or you can consider the Arduino Nano BLE33 and Sense. I think that's the board name, and you can come on this page and you can see the specification. This microcontroller, the Arduino board, have many sensors available. It is TensorFlow Lite compatible, so this is a built-in TensorFlow Lite, and the Arduino BLE sensor combines with different sensors, possibility to run AI using TinyML and TensorFlow Lite. Whether you are looking for creating your first embedded ML application, or you want to use Bluetooth low energy to connect your project or your phone, the Nano 33 BLE Sense will make that journey easy. It has a Bluetooth, it has IMU sensor for motion detection. So if you are detecting some kind of motions and you are making some machine learning models which is based on a motion, just like the accident detection method or anything, you need some kind of gyroscope, accelerometers. There is a built-in sensors available on this board. There is a Python support for this board. There is a microphone available on this board. There is a proximity and gesture detection sensors available. There is a barometric pressure sensor available, and temperature and humidity sensor available as well. And you can consider this board, or if this board is not available, just like this board is not commonly available in Pakistan, you can consider other boards like Raspberry Pi Pico, or you can consider some board, the STM32 versions. Let's talk about the TinyML searches. If you search on a TinyML on the LinkedIn, there are a lot of people talking about the TinyML, researching on a TinyML. And if you scroll down, there is a post which talks about the different available boards which can support the TinyML. So if you are doing some machine learning based project where you are actually doing something computer vision related, there is an open MV board. This is STM32 H7 based board. So I asked the ChatGPT to tell me about this board. And this board has STM32F7 for 6 microcontroller, and this microcontroller have 1 MB of flash. I will talk about the calculations to know about how much flash memory you need. This board has 320 KB of RAM. I will also talk about how to calculate the required RAM for your machine learning based models. So overall, this is the best one. So if you come to the previous methods, just like the SVM, the KNN, the regression, the random forest, these are machine learning methods which are used before the neural network. So if your problem is not that resource hungry, and you can simply train with a limited data, and you can implement this regression based models or random forest based models or rule based systems, this could be easily deployed on Arduino based models. So you need to identify what kind of machine learning algorithms you need. So if you are doing a microcontroller based project where you need a machine learning algorithm, you should consider first of all trying these methods. So if your problem successfully fits under one of these methods, you can easily implement it onto the microcontroller. The KNN and the random forest is a decision tree. Basically, a decision tree is easily implementable on microcontrollers. But if you had to adopt a deep learning based method like CNN, RNN, or you are doing some clustering or dimensionality reduction, so if you are using PCA, NMF, these are other statistical based methods. If you are doing clustering, the k-mean clustering is also a similar algorithm, but we are specifically talking about a deep learning based methods just like a CNN and RNN. Then you need some kind of deep learning library. There is also other variants available of the TF Lite or the TinyML. The similar one is YouthAnswer. YouthAnswer is a library for building the machine learning based models for the microcontrollers. What is it? The YouthAnswer is extremely lightweight machine learning inference framework built on Tensorflow and optimized for ARM targets. So if you are doing some ARM-based microcontroller like STM32 is ARM-based, it consists of a runtime library and an offline tool that handles most of the model translation work. So this repo had all the runtime. If you go down and you see there is a core and a tensors available. So how does the YouthAnswer works? You train some model, you implement that and translate it to C++ with embed supported. So that's how you train your model in a normal Python, and you convert that model for inferring onto a microcontroller which would be converted in C++ 11. So if your microcontroller compiler supports C++ 11, you can utilize this library. But you need to know how much RAM and ROM or flash memory you need. So there is a simple high-level API example which you can see how easy it makes to use this TensorFlow. And you can build for on ARM embed OS as well. There is a building process. You can look into that. And there are other available libraries for this purpose. And let's see what kind of platform you need to talk about. Okay, so we have STM32 Cube AI. You need to pay attention that the makers of embedded systems and the edge devices makers also um, identify that they need to make some tools available to convert this complex and heavy machine learning task to infer on a microcontroller. So they make some tools, just like I introduced that the MP Lab created a plugin for their IDE to convert the Tensorflow models onto their embedded systems, their microcontrollers. Similarly, the STM32, which if you are available of developing in STM32 based devices, you maybe know that the STM32 Cube MX is a very popular visual tool to make some initial codings and for your microcontrollers. Similarly, they introduce STM32 Cube AI. This AI tool for users who have previous experience in creating and training deep learning NN models. So you need some kind of experience in building and creating NN models. This is specifically for NN, so it supports a TensorFlow Lite, Keras, QKeras, or PyTorch. So this tool helps you to convert your pre-trained neural network. So you had to train your model on Python, and then you convert that model with this tool for the STM32 microcontrollers. So you may get the idea. First of all, you need to train your model, then you need to convert that model for your microcontroller, then you deploy that model for inferring onto a microcontroller, and then you make a pipeline where you take input from the sensors, you convert, predict from the inferred model, and then you output or take action what you need. So you take the sensor data, you perform some pre-processing, you utilize some inferring model like a TF Lite interpreter, and you post-process the predictions and you handle the output. And this TF Lite interpreter use a trained model which is converted for your device, and device outputs the prediction or anything that the model is trained on. So that's how a TF Lite or TinyML works. So TinyML, a few machine learning frameworks that supports the TinyML, the famous one are TensorFlow Lite that we had talked, the Edge Impulse. You need to talk about the Edge Impulse. Edge Impulse is very popular nowadays. So how it is, let's see Edge Impulse. Edge Impulse give you some web interface where you can collect the data, you train the model, you convert the model for your device, and you download the code which you can use as a basic scaffoldings and basic starter code for your TinyML based project. So this device, this Edge Impulse is very handy to make start in the TinyML. It makes lives much easier. It has a web dashboard. It gives you visualization. It directly connects with a lot of supported machine learning supported embedded devices directly to this a web interface. You can connect your devices and you can collect the data runtime. You can train on that data. You can download the pre-trained model, convert it for your microcontroller, and it works for you. There is a pricing available, but the free plan is available for students, universities, and individual developers at companies with less than 15 employees. So it is free for them. So it is good to get a start. If you are doing it for enterprise, you can get a custom price, but students always start for free. So a lot of machine learning projects on a TinyML base using the Edge Impulse. So that's how the Edge Impulse makes your life a very easier. I also want to talk about what researches are being done on the TinyML. So on-device training. On-device training is not possible nowadays, but there are some researches where the training is being done on devices. This is one of the best paper which talks about how everything is done. So I will leave the link in the description below. If you want to talk or learn more about that, you can see the paper. And here is the demo available on the YouTube, where you can see that a prediction is done for the live video feed. So if you run this video, it is running on STM32 F746 development board. So it has 320 KB of SRAM and 1 MB of flash. So this is commonly the requirement. But if you are starting with a limited project, just like you want to detect some kind of motion with the accelerometer, you want to train your model on that, you can tweak this to be trained on Raspberry Pi Pico, or if you have a Raspberry Pi Zero, that could also work for it. And next, coming back, the Bayesian methods do not require much of resources. It is a simple probabilistic method, and you can simply do that. And in 1970s, AI winter caused a persimmon about the machine learning effectiveness, and the backpropagation method is invented, and it is a backbone of neural networks, and it boosts the machine learning neural network research. And sport vector machines are coming in the 2010. The deep learning become popular with the backpropagation. The deep learning comes into play, and in 2020, generative AI, where you are seeing the ChatGPT, the stable diffusion, these are all the result of the generative models. So these are not kind of methods which you can deploy on a microcontroller for now. Maybe in future research you can short down them to be supported on embedded devices. So there are a lot of methods: the Bayesian theorem, the least square theorem, the Markov chains, and the Turing machine, and a simple perceptron. If your method could be done with something with the simple perceptron, you can do that on microcontroller as well. Now, how to reduce your model with the deep learning, and what you need to know before you start doing something. Here is another project which I want to discuss. There is a TinyML library which puts the MNIST digit recognition model on ATmega328. So ATmega328 is Arduino microcontroller. If you already know that the famous Arduino, have the ATmega328. So it means that they converted the MNIST digit recognition on it. It is an 8-bit model. So the machine learning model is converted on to be trained on with the TinyML library. So how they do that? Look into this example. They feed this digit image, and it predicts. Let me zoom in if it is possible, but it predicts the output very well. So that's the demonstration of ATmega32, which have only 2 KB of static RAM and 32 KB of flash. So here you can see the potential of TinyML, which could be implemented on 2 KB of RAM as well. So it all depends on how you model your machine learning. So if you go on a GitHub page for their machine learning, the library, their TinyML library, the TinyML is a synonym of TinyML, and it has This library is written for a hackathon project, so it is very limited. Core code less than 400 lines, so you can read it easily, and it can take less than 3 KB in the flash, and it could easily be implemented in Atmega 328 with 32 KB of flash, compared with 3 KB, easily convertible. And you can run MNIST with TinyML port int8 floating point 32-bit or 16-base model. You should be considering int8 based models for your microcontrollers as long as you can. You should stick with int8 or int4 if possible, but if not possible, you should consider FP8 based data type models or FP16. Then FP32, you need more heavier microcontrollers. So this is similarly the input which is given to 328P, and this is output that it predicts. It says 0, and it says it is look like 89% of 2, it look like 1% of 4, 1% of 6, and the prediction output is 2 and probability is 89%. So that's how the machine learning based method works. You give the input, it passes through the model, it predicts the classes and the probabilities. You get the maximum probability, and you output the class with the probability. That's how a simple machine learning methods works. So it talks about there are other libraries available, which is NNOM. This is a higher level neural network library for microcontrollers, is for use for inference neural network library onto the microcontroller. It deploy the Keras models to NNOM model with one line of code, and it supports complex structure, inception. It is a very complex structure, ResNet, DenseNet, octave convolution. So it supports, this library supports that. And that's how it usually works. And you have models in Keras, TensorFlow, CNTK, or Theano. You train that model with Keras model, and it is converted and deployed with a header file with the model.h, and you use that header file into your embed devices with the help of NNOM framework and the hardware implemented on the hardware. So that's how it works, and this is a library visual representation. DenseNet, residual net, and inception models are capable to be utilized with this library. And if you come more, there is a micro TVM. This is from Apache. So this library is also used in TinyML, and with this library it runs TVM models on bare metal IoT devices and depends on the C standard library and doesn't require an operating system to execute. So this is best for the edge devices where you don't have usually available the operating system, although the Raspberry Pi 0 and Raspberry Pi 4 or 3 have the Raspbian OS available, but the microcontrollers like STM32 do not support the OS, although you can implement an OS on them as well, but you need some library which do not usually require. So the supported hardware for this library is STM Nucleo F7. You may notice throughout this tutorial series that most of the libraries are supporting STM32 F7. The reason is heavy flash of 1 MB and RAM availability. But there are some NRF development kits which are also supported. If you know, there are the microcontrollers like the Raspberry Pi Pico which have some similar chip available. So if you talk about specifically this microcontroller, it has a lot of processing speed, 256 KB of flash and 64 KB of RAM. There is another library of TF Lite Micro, This is from the TensorFlow. This is the TF Lite actual port for the microcontrollers. I will give the link for this library in the comment as well, and you can. Let's talk about how you know how much memory you need for your TinyML based project. So the TinyML project is you need to know the RAM and flash memory. So according to the TensorFlow Lite for microcontrollers guide, the library you need, if you build all of the supported features, 125 plus supported operators, you need the 1 MB approximately, and if you link all of that for the 32-bit of ARM builds, and if you are compiling it for only needed. So if you only use the operators needed for supporting the common image classification models like Inception version 3 or MobileNet version 2, the compilation time is only 300 KB, and therefore the flash memory of the device should be at least 300 KB to store the binary and the model, and the RAM should be enough to hold the input and the output. So how you determine how much RAM you need? So the size of the tensors you need to know, and there is a model architecture, input shape, and data type you are using. For example, a simple model that replicates a sine function. So if you are implementing a model which replicates a sine function, the input tensor is size of 4 byte or a 1 float. And if you are using an int-based model, it could be 1 byte, but because we need a float number input, so we need 4 bytes. And output tensor is a size of 4 byte as well, but the intermediary tensor size is 536 bytes. So the totaling of 544 bytes. So if you have this much RAM available, which is also less than the 2 KB of RAM most of the microcontrollers have, you are good to go with that. A more complex model like the image processing model, you need, if for example you have 96 by 96 RGB image, it means the input tensor size is this bytes long, so it is almost 27 K bytes, and output tensor is 40 bytes, which is required 10 floating point numbers, and intermediary tensor is almost 313 kilobytes. So the totaling of 341 kilobytes of RAM you require for an image processing task. There are a bunch of methods to reduce the model size and RAM usage, and you can apply the task like quantizations and pruning and optimizations. The quantization reduces the precision of the weight, and if you are using a floating point, you convert this to integer, and 16 or 8 you reduce the size by 4x. So when you need 4 bytes, you only need 1 byte. So you automatically reduce the model size by 4 times using just quantization method. In the pruning techniques, it removes the unnecessary weights from the model, and it could reduce the size by 10 times. So these techniques could make your life a lot. Now coming back to tinyml.mit.edu, there is a microcontroller net version 1, version 2, and version 3 available. If you read this paper, this is on-device training, which enables the reduction, which I just talked about, and here you can see all of these possibilities in this paper, where you can see the memory where at the ResNet on the Cloud AI it requires 16 GB, and a mobile net, if you implement this on a mobile devices, reduced to 4 GB. But on a microcontroller with a Tiny AI, you need 320 KB. So it is reduced to 320 KB, and here you can see how much the optimization is being done from 4 GB to 320 KB. So here you can see the visual representation of ResNet 50, MobileNet version 2 and MobileNet version 2 with the integer. So here you would see the potential of using quantization process where you don't use, there is a 23x, 22x and 5x better. So there is an algorithms used in this, you can which are supported for TinyML. There are separate algorithms, separate techniques for reducing the model size. There is a save memory for patch inference. There's a lot to talk about in this, but you should start project by project. You should focus what you need on your current project. So if you are only using an accelerometer based project to the microcontroller, which is a good starting point, just like an accident detection based method, you need to know about real-time analysis or something. So we'll talk about that in upcoming videos. So that's all for today's video. I will leave links in the description, so don't forget to check that. If you have any question, you can leave the comment, and don't forget to subscribe.